This conference will now be recorded.
All right, folks, so good afternoon. We're looking at finishing up chapter 5. So this is the skeletal system. So right now we're going to be talking about a few of the pathologies. You recall when I was here, when we were here in class last class on Thursday, I mentioned to you about scoliosis. How about someone here in class tell me what is scoliosis? Do you recall? Go ahead.
Curvature of the spine.
Okay, that's a very good way of putting it, that curvature of the spine. And so what goes on is that if I have, so remember this drawing that I put up here on the board that was very basic, but let me get my markers here. All right, so you recall that I said to you that here would be, this would be normal. If I'm looking at someone at their back, if their back is towards me, they're facing away from me, their spine should be straight, okay? Now, if we have a patient like this, that represents scoliosis, recall, right? So now understand also that as we look at the spines in the back, okay, so let's look at the full articulated skeletons in the back. So as we look at this one right here, okay, so there should be, now these have been, abused and moved around and different. So, but understand that there should be a forward curve in the neck, curve in the back that comes out more, okay, forward curve in the low back, and then sacrum kind of comes out. So we would say the back portion of the body is posterior. We would say the front of the body, anterior. Front, anterior. Back, posterior, okay? So as I'm looking at a side view, or we call it a lateral view, right? There should be a forward curve here and a forward curve here. In the cervical, the neck area there, the low back, the lumbar region. There should be forward curves. The primary curves here are in the mid-back and in the sacrum. There's a curvature that's going posteriorward. Let's look at the board. Go ahead.
What's the word for the front of the body?
Anterior. So we would say anterior, front, posterior, it's the back, okay? The curves within a healthy body, forward curve of the neck, backward curve of the thoracic area, forward curve of the low back, and then the sacrum is curving that way. So we would say that the thoracic curvature, this is on a side view. This is called the lateral view, and it's really way off. Let me correct that. Side view is called the lateral view. Lateral. Looking at the side, okay? So as I'm like this, that's the side view that you're all looking at, okay? So there's the head, nose. So the primary curves is your mid-back, your thoracic region, we call it, and the sacrum. The sacrum acts as, see this piece right here on this image right here that I've driven, right? Drawn, driven, right? What the heck is that? Drawn. So triangular shape, that's the base of the spine. That would be the sacrum, okay? Sacrum. So the sacrum curves a little bit posterior and the mid-back posterior. So here's the drill. Here's the drill. Here's what's going on. Let me just get you here. So for a fetus that's developing, a little baby that's developing, right? They're kind of like this a bit, like a C curve. Understood? That's that primary curve. That's this, the thoracic and the sacrum. What happens is that when a child, as they're able to start to creep and crawl, what do? You put them in tummy time. You understand what I'm saying? They're on their stomachs. They're on their stomachs. And so what happens, right? Yep, they raise their heads up. This helps to develop the secondary curve, that forward curve in the neck, the cervical region, as well as in the low back, because then they start pushing themselves up, and that promotes that low back curve. So these curves are healthy. Now you can have them accentuated by different types of arthritis and such that can make it worse. Ellie, you have a question?
I was going to ask if it was a healthy back curve.
These are, yes, these are healthy. These are important to have those curves. So really on the side view, if you were pretty much like this, right? Maybe the curve there, that is not healthy. And that's also not strong. So the spine is much stronger with these lateral curves, with these side curves, right? And so we call the primary curve is a kyphosis. The secondary curve is a lordosis. And so chiropractors work on these. We try to help promote these curves when we're adjusting patients and such, so that we can do different things in order to promote healthy curves. Primary and secondary. So the primary curves.
I thought that's how much they were.
Yeah, no, you're thinking of degrees. Yeah, so question.
Yeah, so 1 degree is the neck.
Primary?
So the neck.
No, primary curves, look at this. The thoracic and the sacrum. That's the primary curves. Secondary curves are the cervical and lumbar. And those curves develop early on in developmental stages for an infant and child. Okay. Now, things can happen, like say being involved in a car accident, an auto accident, having a whiplash type injury, that can really mess up these lordosis or these secondary curves, right? And that's a problem, where it would decrease the curve. Instead of having a nice forward curve, there would be a much less curve. Now, understand also that you can, so a process where things are not functioning like they properly should, you can have too much of a curve or too little of a curve. Does that make sense, right? There's a good healthy curve, but if you have too much of it or too little of it, of that curvature, that's a problem. And that can lead to pain and discomfort. That can lead to headaches. That can lead to sciatica, pain passing down the buttock area there into your legs. Yeah, it's no fun. That's, pain and discomfort, and just lack of real good structural, lack of good structural support for your whole body, having issues with these curves. So again, scoliosis. So there's the term, scoliosis. Those are bad curves, curvature of the spine. These are healthy curves, the kyphosis and the lordosis, healthy curves in the spine. Okay, very important. Now you'll see here. Give you a moment. You'll see here on the board, okay, and on the computer here for those online, that I have an image of healthy bone, and this is that spongy bone, that trabecular bone, spongy bone. See, it's got the holes. But look at this one here on the right. The one on the left is healthy. The one on the right, yikes, the areas of the bone. Remember we said that lattice, L-A-T-T-I-C-E, lattice work of the bone. That's not good on the right-hand side. Folks, this is not good over here, right? So where bone should be what? nice and hard, but living tissue, and it's full of blood, right? There's a lot of blood present within the bone. Healthy to the left, unhealthy to the right. This is demineralized. This is very porous, and it's not strong. The bone on the right is very susceptible to fracture. That's bad, right? So we have stages of demineralization of bone called osteopenia, which becomes osteoporosis. So that's not a good thing. And that's why we'll have women go for bone density tests in particular, but males also can have issues with this, but primarily it's more a female issue. Go ahead. So yeah, so I mean, genetics play a role in this also. You have to know that, but improper nutrition, lack of exercise. So if someone is very sedentary, what did we say about bone? If I put pressure on bone, right, it becomes what? Stronger. So if I'm punching a board, will this arm get more dense as far as the structure of the bones and such? Absolutely. Will weightlifting, exercising, will that increase bone density? Yes, it will. So the more we do that, so this is why we can have our elderly patients and people who are getting older, right? You hit the 50s and onward, you know, there's more demineralization taking place, muscles weaken, bones weaken. That's never a good thing. So we want to have people exercising. So we all need to be doing some type of exercise, right? If you have a job where you're sitting for most of the day, it's not a good thing, right? You need to actually just do exercise. It's really important. All right.
Why people get little under the desk exercise machines?
Yeah, absolutely. Yeah, just to kind of keep things moving. But I'll tell you, even though you have like something that's like moving your feet and such, you really need to just get up and change positions and such, because just sitting itself is never a good thing for too long a period of time. Here we're just seeing this next image. We're seeing that we have a replacement for the knee. Here's the patella, the kneecap. You can see the hardware. Now, sprains, a sprain, small tear, cross out the ligament there, to tendon there. Because primarily what it is, a sprain is overstretching. So write this definition down for a sprain. Overstretching and tearing of ligaments. Sprain, sorry. Sprain. Ligamentous, okay? Overstretching and tearing, whether it's minor tears, micro tears, or major tears, okay? That's a sprain. So a strain, S-T-R-A-I-N, strain is the same thing except it's for tendons, okay? Overstretching and tearing of tendons, and you'll see here what? The T, strain, the T, tendons, okay? So you can tear, and there's also muscles are involved in that too, because what's the extension of muscle but tendon? Go ahead. Yes. Yeah. Yeah. So it's some type of, really what happens is that you've damaged it somehow, right? And yes, the musculature can be very tight, and as such, it's not been. And so what happens is that tight muscle, you've overstretched it. What's going to happen? Can you and if it's done quickly and such, a damaging way, you've done some type of tissue damage to the muscles, the tendons, or both. Question. Well, so you should have it put back, replaced. Yes, you should. If you could do it yourself, it'd be it's a difficult thing. Now, here's the drill. Some people can help to reposition their shoulder because of the fact that they've done it multiple times, unfortunately. So there's quite a bit of ligamentous instability. It's a painful thing. I mean, I can't ever imagine replacing your own dislocated shoulder, to be honest. Yeah, so no, what's going on is that, do you recall, I talked about early on in class that if you have popping and clicking in a joint, that means you've damaged that joint somehow. And there's an instability going on in that joint, and so that's what's happening. Yeah, indeed, that's what's happening. So you've overstretched the soft tissue, the ligaments and tendons that are helping to keep it, in particular the ligaments that are keeping that joint tight in place, they're overstretched. That's why you shouldn't, when you move a joint, you should not hear any popping or clicking. If you do, you're in trouble now. You have an issue and you have to get checked out. Indeed. Okay. All right. So you'll see here that fractures, we'll look at an image in a couple of minutes here in just a moment. There are different genetic diseases, infections, cancers. There are multiple issues that can go on with bone. Go ahead.
Is it true that a sprain is worse than a fracture? Because somebody.
Yeah. Okay. So here's the thing with that, right? So with a fracture, you've got a minor break, or you've got a major break, whatever it may be, but that will heal over time, right? And that will heal stronger. With soft tissue, so ligaments and tendons, yeah, that actually can take even longer to heal. And what happens many times also is that if it's not, people won't stabilize it like with a cast, although, you'll see people that'll have like, maybe a shoulder situation, bracing and such. See, that would be important short term to get it to help to knit together, but then you have to like start rehabbing it and such. So soft tissue injuries can take longer to heal than hard tissue like a fracture. So let's take a look at this image right here that we have coming up. And here what you're seeing is that you have different types of fractures, okay? And so what can occur also is that fractures that are actually breaking the skin. So you actually have components that are actually exiting from the wound and such. And you're noticing here, right? It's red because, yeah, they bleed, right? We said fractures bleed because bone has a lot of blood supply. Here we have this next image here. Here we go. Here's an example of a young child with osteogenesis imperfecta. And so let me go out onto the web here for a moment. And you can see that bone should not be bending like that. It shouldn't be soft. There shouldn't be any type of issues where it's deforming like it is, okay? Now know that with kids really can adapt, and yes, they can have fractures and such, but their bodies are, their skeleton still is in the process of growing and changing. And so, give me one moment. Okay, so here you're seeing an example of osteogenesis imperfecta. Healthy bone in the classroom to the left, to the right, the brittle bone. You'll see it online here, we have the healthy bone above, the brittle bone below that. And so what's going on is that this bone, as a result of a genetic disorder, right, is not healthy. It's going to be susceptible to deformation and fractures and such, and multiple fractures actually. The sclera, the white of your eyes, that's called the sclera. The white of your eyes, right, the sclera, that can have a blue tint to it. So those people who are suffering from this can have this kind of a presentation, we would say. And this is just one example of, there's also something called Paget's disease, and where we'll have excessive bone growth, in particular in the skull. We'll see that Paget's disease, and the skull will get larger over time, but it's not healthy bone. It's bone that it's unhealthy and porous and just not good stuff. So there are multiple types of disorders in the skeletal system. So just looking at that there as far as that osteogenesis imperfecta. And you're seeing here the arm bone, right? The humerus. This has been deformed with that process there, osteogenesis imperfecta. Okay. So finishing up this chapter here, just a couple more slides. All right. So as far as homeostasis is concerned, right? So this was a question on the quiz and such, and you all did very good with this. I'm pleased with that. Thank you. Yep, you're reading, you're looking at it, you're going through the material, so very good. So stable environment, no matter what's going on outside of the body, inner side, the inner area of the body, the internal regions of the body, we're maintaining different levels of temperature, of different types of secretions, whatever it may be, blood pressure, we're maintaining these levels at a set point, right? If it goes above or below that set point, the body will, through these homeostatic changes, and in particular through negative feedback, bring it back to where it should be. So, skeletal system, what's going on with the skeletal system and homeostasis? Well, what are the functions, right? Support, protect, and move body parts. Absolutely, right? This simple, you get it, you understand it, right? In conjunction with the skeletal muscle, we have the muscle attaching to the skeleton and being able to move it, allowing the patient to be able to move. Protecting the vital organs. How about as a bank? Remember we talked about this, right? Calcium and phosphorus. So reservoir, we need this. So look what it says below. Somebody read that for me. Who wants to read it? Yeah, so it's really important for what's going on in the nervous system and the muscular system in order to have this calcium, enough calcium for these different processes to take place. Very important. Let's move on for a moment here to the next slide. And you'll see here as far as the integumentary system, the skeleton, what does it do? It provides support for the skin and muscles. Muscular system, working in conjunction to move the body. As far as skeletal muscle, provides levers for body movement. Calcium can be released to contract muscles. Remember I said that, very important for the nervous system and the muscular system to have plenty of calcium present. The digestive system, dietary calcium and phosphorus, it's important, so it acts as a bank for that. Cardiovascular system, again, calcium is important for muscle contraction. This is not only just for skeletal muscle, but for cardiac and smooth muscle. Where do we find smooth muscle, folks? Where's smooth muscle located?
Involuntary.
Involuntary, and where would you see smooth muscle? Organs. There you go, right? Because we don't have control over it, and it's allowing for movement to take place in the different organ systems. Recall also that we have blood cell formation in the red bone marrow, right? So the immune function, the white blood cells that are being produced in the red bone marrow. Respiratory system, we have protection of the lungs, which is vital for life, right? That we can respirate. Rib cage, sternum protect the lungs. The urinary system, right? Pelvic bones are protecting the bladder. Also, the rib cage allowing for protection of the kidneys. This is where filtering blood in order to produce urine and remove waste products. That's the urinary system. The nervous system, needed for the ability for the nervous system to communicate with all parts of the body. Calcium from the skeletal system. Sensory systems, again, in order to maintain that communication between those sensors in the body, those receptors, and the rest of the body and the brain, the CNS, the brain and spinal cord, very important as far as calcium is concerned. Endocrine and reproductive systems. Calcium is in bone is released as needed to maintain blood calcium levels. And there are different hormones that we'll look at in the endocrine system that are going to help to allow for increasing blood calcium levels when it's needed. Okay, so there's hormones that will help to help the body's the cells within the skeletal system to release calcium and break down bone. And lastly, the reproductive system you're seeing here, pelvic bones protecting the female reproductive organs. And again, calcium important for nourishment of the fetus and milk production as the baby is born and feeding the child. And this last image here, last slide, is just showing you axial and appendicular, and you should know this. Okay, you should know this. This is important to have an idea what's present as far as what bones are in which part of the two skeletal systems per se. Okay. All right. Okay, folks. Let's everybody stand in the room here, or just stretch it out a little bit. I'm going to now go back into, and we're going to put up. There we go. Chapter 6. Now, before we look at chapter 6, I want to be able to show you all another genetic type disorder. So chapter 6 is the muscular system, and we're going to be looking at FOP. So let's trying to remember where I was looking at for this information here. There we go. So FOP stands for, and I'm going to write it on the board. So I'm trying to find where I was at here. Here we go. Now understand that with FOP, fibrodysplasia, I'm going to write it here on the left side of the board here. FOP, fibrodysplasia ossificans progressiva. So write that down, please. All right, let's see. FOP. So this disorder is a very unique disorder. Okay? So why is it unique? Because we can have soft tissue, we can have one type of tissue become another type of tissue. Okay? This what happens with this is that we can have muscle, ligaments, and tendons ossify. Muscles, ligaments, and tendons can ossify. They can become bone, folks. So the body, through this disorder and through certain triggers, can initiate the reaction where soft tissue, muscle, ligaments, and tendons can become bone. They can ossify and become bone. How is this a problem? You tell me, what do you think? How is this a problem? Go ahead. That's right. Exactly. Exactly. See? So that's, Ellie, you were going to
I was gonna say
contribute?
you can't really.
think about that. So what'll happen is that it doesn't happen all at once, that they're just all like, they're like a board. No, that's not happening. But can this be a progressive type of disorder where they damage an area and they get these hot spots where then muscle will replace bone? And especially if it affects joints, if it affects a joint can become locked. So can you imagine your arm being locked like this, and you can't do anything? You can still use your hand a bit, but it's locked, bent. Go ahead.
So if you, in like severe cases, is it possible for it to like stop your heart and lungs and stuff?
So as far as that's concerned, so I would say more of there's a restriction that can take place between like the muscles between the rib cage, between the ribs. So we would call those intercostal muscles. So how many of you like to eat ribs, pork or beef ribs, right? I think many of us, if you're not a vegetarian. Yeah. And so what you're eating are these intercostal muscles, but these are important for your ability to breathe, in addition to your diaphragm, right? But it allows, so can you imagine if those start to ossify? Then you're really affecting what's going on as far as your ability to breathe properly. Absolutely. Question, Mary. Yeah. Yeah, so that's more of a, yeah, understood. And so what'll happen is that there are different types of, like electrolytes. You know what the electrolytes are, right? You've heard like sodium, like salt, sodium chloride, right? These are different ions and electrolytes that can have an imbalance. And if you're not having them present within your body, there could be something going on as a result of a medication, as a result of improper nutrition. I don't know. There can be issues where you can end up having and developing, like at the end of a night, lack of magnesium is another one. Magnesium is good for us, right, to take, and that can bring a calm and relaxation of musculature that's tight and such. If it's not present, you get this Charlie horse. And, oh my gosh, have you ever gotten a Charlie horse, right, where it just, the muscle just like cramps, and you're just like, yes. Yeah. Oh yeah, because it's like you injured it. Yeah, and now it takes a while for it to relax and calm down. All right, so FOP. So I think what I want to do, folks, let's see, did I share this? No, I didn't share my screen with you all. Sorry about that again. I'm coming back here. So this is the website. Let's see. So look at this right here. I'm scrolling down to this image right here. So one of the odd presentations for this FOP, we can see this in infants, is that look at what goes on with the toes, the great toe. The great toe is like really cranked, right? And it's in an improper position. It's not, yeah, it's just, this is a presentation where we say, hey, this child could quite possibly have FOP. This is a very rare disorder. I'm going to share with you a short video, and then we'll get into our chapter. Yeah, this is an older video, but it's only 4 minutes long. I'll play it just so that I skip the commercial.
Oh my goodness.
Okay.
You messed up.
All right. All right, those of you online, I'm going to have my screen play your, let's see here. Do this, do this. Okay. All right, folks, so no talking, please. Let's watch a short video.
These people live with a mysterious condition with no known cure called myelodysplasia ossificans progressiva, or FOP. FOP is one of the rarest conditions known to mankind. We need to go plenty of stages in order to find one person who has FOP. In the United States, there are fewer than 300 confirmed cases. It's an extraordinary condition that causes bone to grow unchecked where it should. At any moment, with the slightest trauma, even a simple bruise, muscles, tendons, and ligaments can turn to bone. Joints can fuse, threatening to imprison patients in a second skeleton. And once the new bone forms, it's there to stay. FOP is the worst form of unwanted bone formation known to mankind. It's also a metamorphosis unique in human biology. The only case known to medical science of one organ turning into another. Probably the heart doesn't become the lungs, the liver doesn't become the kidney, but in FOP, the muscles, tendons, and ligaments become a second skeleton. Good. So you're at first glance, 28-year-old Holly Polano appears to suffer from a particularly severe case of arthritis, but she's been living with FOP since the age of 16.
I live with FOP every day of my life. The scariest thing about FOP is that it's permanent.
I'd like to take a look now at the range of motion in your neck, and I'd like you to look down for me. Can you look up? Okay, so that's about 50% of normal.
Over the 12 years that I've been living with FOP, it's affected numerous areas of my body, including my neck, my back, both of my arms, and my shoulders.
Those white areas are where new bone is formed.
Dr. Kaplan is the leading expert on FOP, having examined virtually every patient worldwide. Let me take a look at your back.
Sure.
Patients like Holly can experience new bone growth at any time. The first signs are painful swellings called flare-ups. I see here some areas of old bone formation, but they look old. They don't look like new flare-ups at all. Since muscles develop micro tears when they are pushed beyond normal use, something as innocuous as basic exercise could trigger a flare-up, or something as severe as a fracture. Basically, anything that results in inflammation, the body
See how
responds to physical trauma.
That's not
Could be
normal.
the beginning of new bone growth.
If I have a flare-up, which could be caused by a simple thing such as bumping into something, I'm faced with the fear of knowing that that joint or that organ can lock up forever.
When a healthy person experiences trauma like a bruise, the immune system kicks into gear. Immune system cells flock to the site of the injury. They consume damaged tissue and repair it. But when people like Holly experience the same injury to their muscles, tendons, or other tissue, these cells cannibalize the body. They ravage both damaged and healthy tissue in the trauma region. In the wasteland of dead tissue, a few living cells remain. They are stem cells, cells able to transform themselves into different types of tissue. While in an ordinary human, they would form into scar tissue or replacement tissue. In FOP patients, they morph into cartilage and then bone. Eventually, ribbons and sheets and plates of bone replace the body's skeletal muscles, cross the joints, lock them in place, and render movement completely impossible.
All right. Okay. So let's. Not really a fan of Subarus, but anyhow, go on. So this FOP is really quite a devastating disorder, folks. It really is. And so here's the thing to remember. If something looks painful, more than likely it is painful. And so when you see people moving around slowly, yeah, it's because they're in pain, right? So yeah, so that's tough stuff. And in particular, we're talking about here as far as with these patients that their ability to move, their range of motion, is really messed up indeed. Yep. So there's that FOP. All right, I'm going to share my screen now with you all online so we can go back to the PowerPoint. All right, so we're in chapter 6. And so I just thought that that would be quite interesting to discuss with you a little bit regarding a pathology that really has a very close relationship with what's going on as far as with the muscular system and with the skeletal system in particular. And realizing also that, so we've talked about skeletal muscle. We mentioned also earlier today, smooth muscle for all the organs of the body and all like the vessels of the body, smooth muscle, involuntary control. Skeletal muscle, voluntary control. Cardiac muscle, involuntary, and that's for your heart muscle to be able to beat and such. So that's really important. Elias. No, go ahead.
People with FOP, are they able to like voluntarily move the new bones that show up, or like probably not?
Yeah, so here's the drill. Depending upon where that soft tissue has formed, has been replaced with the bone, it's gonna restrict the range of motion. So here's range of motion. So the ability for me to be able to do this, that's called range of motion. To be able to bend my head, extend my neck, right? Range of motion, the ability to move. Depending upon where the bone has formed, it can limit range of motion or totally eliminate range of motion and lock it into place. So depending upon what, so they need, so if a person, and they're not, it's not like they're always in this state of problem, only that once bone is formed, it doesn't go away. You understand? And if they were to have surgery to remove that new bone, it would create more new bone. Even if you replace the old, there would be new, because of the trauma of the surgery, it would, and there's a woman. Yeah. So it's really sad. It really is. It's a progressive disorder. It's a chronic disorder that only gets worse. It doesn't get better. That's sad, right? That stinks. That is.
But
Yeah.
like, these
Yes.
people, do they live?
So their life expectancy, all depending, right? And so here's the thing. So how about this as far as affecting, like I said, those intercostal muscles? How about affecting the jaw, right? The muscles of the face, right? So it can affect, because that can affect your ability to eat, your ability to breathe, right? That's tough stuff. It really is. So yeah, this is a devastating illness. And he said, what did he say? Something like 20 football stadiums to have one person. Like the odds of it are very, very, very minuscule. That's a good thing. It's rare, but still, it's not rare. And, it's how about if you're that one that has it? Question?
Oh no, I was saying it's mildly horrifying.
Yeah. Oh, indeed. So skeletal muscle, long, thin cells. Now, any type of muscle cell, we'll call them muscle fibers. Understood? So muscle fiber, muscle cell, same word. Okay? We would say it's also known as, AKA, muscle cell, AKA also known as a muscle fiber. Okay? So there's long. So let's look over here, folks. Look at this. Look at this model over here. So we see here, left upper extremity. See this biceps brachii? Guess how long those muscle fibers are in the biceps brachii? They're from here to here. They're long muscle fibers, understood? As long as the muscle is, that's how long those muscle fibers are. Hence, it says over here on the board, skeletal muscle, long, thin cells, those muscle fibers. Smooth muscle. Smooth muscle, these are spindle-shaped muscle fibers. So what would a spindle-shaped muscle fiber look like? Under the microscope, like this. That's the nucleus, and they're kind of spindle-shaped. It looks like they took the muscle fiber, and made it's oval, and then the nucleus was stretched. That's a spindle-shaped muscle fiber of smooth muscle. Smooth muscle, there's no striations, but skeletal, and cardiac, they have these striations. So we'll see that in a moment. So here we go with the next slide. Cardiac muscle. There are branching of the muscle fibers in cardiac muscle, and there's striations present. So this next image just gives you an idea regarding what's going on. So here we have long muscle fibers for skeletal, spindle-shaped fibers for smooth, and branching taking place in cardiac muscle with striations and skeletal muscle striations. Those striations are present because of certain proteins present within the muscle fibers, within the muscle cells. Okay? We'll just go a few more minutes, folks, and then we'll take our break. Here we have an image that I would like you guys to be able to review and to know. And in lab today, so I'll pass these out now. So this is for lab quiz number 1. So front and back, okay? This you all will have to know. Now, you're going to be giving a form very similar to this when you have your lab quiz, because remember I said you have what? You have a word bank. So here's the word bank. So pass that around. It'll get around to both sides of the room. It is correct, but I just printed it out for you all. Those of you online, that lab quiz number 1 document will have all the terms that you'll have to know for the lab quiz. Okay, so you'll see here on that page, on the front of the page, it'll say muscular, and you'll see these are the muscles that it asks you to be able to identify during the lab quiz. So on the other side of the room, you'll get it in just a moment. But you'll see here that there's some muscles of the face and skull. There are neck and torso muscles, upper and lower extremity muscles, just some basic muscles that I'd like you to be able to know and at least identify. If you have the term in front of you, say, oh, hey, I know that's gluteus maximus, right? That's an easy one, right? That's the buttocks muscle right here, right? How about latissimus? You know, people say, oh, my lats, right? Or my traps. Here's trapezius, here's latissimus, biceps and triceps. We know that, we've heard that before, right? The quadriceps. Quadriceps are the anterior thigh muscles. The hamstrings, a group of 3 muscles for the posterior thigh muscles. And so this on your PowerPoint, you can click on it and it'll just help you to identify the structures and such. Okay, so let me just show you all here. And so here you have that second slide that you'll be able to help kind of like challenge yourself to try and remember what these muscles are. Okay, all right. So look at these terms here as far as muscles produce force by contracting. So meaning that if I have some type of load, some type of weight that I'm holding on to or pushing up against, by muscles contracting, I'm able to move that. We get that. That's not hard, that we understand that, right? After a muscle contracts, it's going to relax, right? So you know contraction of muscle as when muscle contracts, it gets shortened. The muscle belly tightens up, right? Now, know this, folks, that so you can have a couple there's different types of muscle contraction. So if I contract biceps brachii, what happens to that muscle? Does it shorten? It does. It shortens. Does it not? You all do that. Please do that for me now. You all do that, right? No, so I've got some guns there. No. Shortens, right? That's a type of muscle contraction. How about put your hands on your belly? Put your hands on your belly and go like this. No, don't do that. Just put your hands on your belly and tighten your muscle. I love your laugh, Agnes. So that's awesome. So tighten your muscle and don't go like, oh no, but tighten your muscle and you can feel under your hands, tighten your muscle. That's another type of contraction because, so here's the drill. Did you feel your muscles underneath your hands all of a sudden like shorten up? That didn't happen, right? Not like the biceps, right? But it still had gotten tight. So there's a couple different types of muscle contraction that can take place. Now, see these terms here? Antagonistically. Oh, it's terrible. And synergistically. So a synergist and an antagonist. So think about this for a moment, right? So the biceps and the triceps, okay? Biceps allow for this action. Triceps allow for this action. Biceps, triceps, right? We would say they are synergistic or antagonistic. What do you think? Antagonistic, because they perform opposite actions. But synergistically, biceps, and there's also a not only just the biceps of the brachialis muscle, there are muscles that will work in conjunction with each other to allow for. So how about quadriceps? How about hamstrings? The quadriceps as a four quad, right? Four. Those four muscles are synergistically working together, but they're antagonistic of the three muscles that are the hamstrings. Does that make sense to you all? So antagonistic, synergistic. Okay, good. All right. I think we'll do this next slide and then we'll take our break. Okay. So tendons we get. We understand tendons, right? Tendons are anchoring muscle to bone. Tendons are anchoring muscle to bone. So if I have a strain, muscle and tendon, right? Overstretching, tearing, not good stuff. Okay. But go up above. Bundles of muscle fibers contain myofibrils. So think of these as like, these are the next smaller level of a muscle fiber. So muscle cells are made up of, muscle fibers are made up of these myofibrils, right? They contain units called that allow for contraction called a sarcomere. I'm going to show you guys in class, and I'll show you all in online. Let's see here. Ooh, I don't have it here. All right, I'll get it during the break, or I'll have it for next class. I don't want to interrupt the other class here and there. It's called a sarcomere, and it's just a model that's going to represent this, but your muscles are comprised of many, I don't even know how many, I'd have to look it up, but many of these little contractile units that when you do this, those sarcomeres, they all contract together, they shorten. And so what happens is that you'll have different fibers, these would be protein fibers that will actually slide and allow for then the contraction. When they slide upon each other, they become contracted and smaller, so the muscle tightens up. And so when you relax, what happens? The muscle stretches and relaxes, right? And lengthens, it gets longer. Yes. Yeah. There you go. Yeah. So you're contracting that group of those four muscles and such. And yeah, so the contraction will help to tighten it and to make it a little bit shorter, right? And really, what'll happen is that if you contract quadriceps, it's really allowing for a knee extension, right? But then knee flexion, by bringing my knee back, hamstrings, knee extension, quadriceps. Okay. All right. So this is good for you to kind of have an understanding that, yeah, these muscles are made up of other smaller microscopic units that will work together. Now, one more thing. So the tendons are allowing for movement. They're anchoring to bone, and they'll slide inside a fluid-filled sac called a bursa. How many of you have heard of somebody having a bursitis? Yeah. So a bursitis, is anybody who has bursitis a happy camper? They're not happy. It's uncomfortable. It's very painful. And so there's an inflammatory process going on, and there's swelling. There's edema that's taking place. Excuse me. And so the area where there's a bursitis present, it's going to have swelling. It's going to be red, painful, uncomfortable, and limit someone's range of motion. Okay. All right. Let's see what the next one is. Yeah. So I'll just show you this image and then we'll take our break. So take a look here, and you're seeing that. So this would be a side view, lateral view, and you're seeing here, they're seeing musculature. You're seeing the fluid-filled sacs, the bursa and such. You're seeing here this synovial joint right here. So Yeah, really, and you're seeing tendon and muscle and ligaments present. All right, folks, very good. So let's take a break. We'll take 15, and I'll see you back in a little bit. Okay, let's stop recording for a moment here.
This conference will now be recorded.
Okay, folks, so we're starting back into the chapter here for chapter 6 for the muscular system. And so I don't want you to get overwhelmed with, as we go into the next chapters and such, with a lot of information. Okay, so yes, there is a lot of information, but I want you to know that I'm going to focus on what it is that you need to focus on in order to take the quiz. Understood? So that's important for you to keep that in mind. Okay, so let's take a look here, and we're looking at muscle operation. How does muscle function? The physiology of muscle. Okay, so the anatomy of muscle. Yeah, we see this guy in the corner over here. That's the anatomy of muscle, right? We see over there muscle and such, and we'll look at those or in lab over the next few weeks and such. But physiology, how the muscle functions, how it works. Okay, so bones and skeletal muscle work like a system of levers, and we're going to have areas where muscle will anchor to, will connect to, will hold on to the bone. Because when it does, God bless, when it does contract, what's going to happen? We're going to end up moving bone. So there's an origin and there's an insertion. The origin, when we say the muscle origin, that's usually like the anchor. Write that down. The origin is usually what we would call the anchor, A-N-C-H-O-R, anchor. It stays relatively motionless. It's not really moving, the anchor. Okay, if you have an anchor, you throw it into the ocean, right, or into a body of water, it's heavy enough, it's gonna hold on, it's gonna like sink in place, and it's not gonna move. Well, in theory, you know, depending upon how much the water's moving and such, but it should be heavy, it should be anchored, it should not move. The insertion, on the other hand, right, when you have muscle contraction, then that's going to attach to the bone that moves. So if the biceps brachii is inserted to what's going on here in the forearm, what happens? So we would have then radius and ulna, those bones right there, your forearm. When I contract, the insertion allows for then the movement of bone. So the origin is the anchor, doesn't really move much. Right, stays relatively motionless, but the insertion, yeah, that's connected to, that's anchored, that's really connected to the bone or bones that are going to actually be moving when contraction takes place. So you'll see here when muscle contracts, it pulls on the bone to which it's attached. The origin is going to anchor, the insertion is going to move. That's important for you to know those two terms there, origin, insertion. So here we go. As far as this next slide here, you can see the antagonistic muscles, biceps brachii, triceps brachii. They both have opposite actions when they contract. And so what are we seeing here? Look at here, biceps brachii. Here's its origin up here, more in the scapula and passing through parts of an area, a groove, bicipital groove we call it, of the humerus. And so what's going on? Origin, anchor, insertion. When the muscle contracts, it's going to move that area that it's inserted to. Okay, so we have then the forearm will then what? It's going to flex. It's going to move. It's going to move closer to the humerus. Triceps brachii can do the same thing, right? So if here we have an arm in flexion, triceps brachii will allow for what? Arm extension. Yes. Okay. Very good. Okay. Now, this area here, it's important to make note of this, but I don't want you to lose sleep over it. So slow twitch and fast twitch muscle fibers. We want you to know that there are different types of muscle fibers present in skeletal muscle that will, some are more for, they're for, your muscles have a combination of these type of fibers present. Now, genetically, you can have some of more of these present than others as far as more slow twitch or more fast twitch. You ever notice that some people, they can be like, they're fast runners, right? But then other people, they can run for a long distance, right? So depending upon the combination of them and how many fibers are present that can give that genetic predisposition towards. But how about training? We understand that training can also help to increase this, because we get it that, hey, if you start out and you only can run like a quarter of a mile, and then over weeks and time, you're able to run a few miles, that's as a result of training, right? And conditioning and such. So slow twitch, right? Contract slowly. Contraction can be sustained over a long time period, right? Fast twitch, well, contract rapidly, rapidly, and powerfully for short periods, but can't sustain that contraction for a long period of time, the fast twitch. So slow twitch, slower, longer lasting, fast twitch, quicker, shorter lasting, okay? Not as much of a duration. Fast and slow twitch muscle fibers. And here you're just seeing, as far as just showing you also that there are, so cross section of muscle, and you're seeing that there are a combination of fast and slow twitch muscle fibers. Now, this next slide here, you'll see the term sarcomere. Sarcomere. This is the basic unit of contraction. The basic unit of muscle contraction, the sarcomere. In particular, this is of the skeletal muscle contraction. Okay? It's composed of thick and thin filaments. So muscle, we said there are myofibrils and there are these myofilaments. Thin and thick myofilaments. So look at this here, right? This will help you. Actin, actin, thin filaments. Myosin, thick filaments. So actin and myosin. These are these proteins, right? These myofilaments, these are very important as far as they have the ability they contribute to the contraction of the muscle, and one moves upon the other. We're going to see that in a moment. But just so I want you to know what a sarcomere is. I want you to know that there are thick and thin filaments that compose a sarcomere. And I want you to know that thin are actin and thick are myosin. All right. This is just giving you kind of the basics of skeletal muscle, its actual, at a microscopic level, what's going on. So here, this next slide. So here what we're seeing is that, look down below here, this lower portion right here. That's an example of, this is an example of the sarcomere. Again, next class I'll show you a model that we have here in the lab that you can look at and see how one moves upon the other. And in particular, notate this, actin, which are thin, that's what slides. Actin slides. Myosin doesn't move. Myosin is stationary, and it's these filaments that are present. So actin slides upon myosin. And that's what's going on. So when you do this, right? Do this. What's going on? Actin is sliding upon myosin filaments. Okay, it's sliding, and so when the muscle belly gets shorter, that's because of what goes on with actin sliding upon myosin. All right. Contraction. Now this is pretty interesting, this next slide. So ATP, right? ATP is a very important, have you ever heard this term ATP? You might have, right? In a biology class or something, ATP. So it's necessary for certain reactions to occur. let's keep it as basic as that for this point in time. And so you'll see here that on the top area, it says actin slides over myosin. Myosin doesn't move. Actin is what moves. The thin myofilament, that moves. The thick myofilament doesn't move. It's stationary. Calcium is also very important. Without calcium, we're not going to be able to have that sliding taking place. I want you to know that. And really, there's also at the beginning stage of a muscle contraction and at this stage of the sarcomere, if calcium is not present, it's really important. If it's not present, you're not going to have muscle contraction taking place. So it's really important. Now, rigor mortis happens at death. You know what that means? What does it mean? What do they call a dead body? A stiff. Because why? It literally does. Yeah. Right. And what happens is that these cross bridges, the actin and myosin connect. And what happens is that myosin, let's go here for a moment. I'll come back to this. So look at this. This image here, you're seeing myosin is like pink, right? Myosin is here. Here's myosin. It's kind of purple on this image here. That's myosin, the thick myofilaments. It's stationary, doesn't move. But meaning that there is some movement taking place. There's a pivoting in that it has these little arms. You see these little golf clubs? See those golf clubs? They're an extension of the myosin. And that golf club will connect to the actin. See this right here? That's actin. Actin, thin myofilaments. Oop. Actin is thin. And what will happen is that the clubs connect. We call that a cross bridge. They're connecting. We call that what? A cross bridge, right? Cross bridge formation. There's a connection. And once it connects, that myosin is going to then move and the sliding will take place of actin. Remember we said this, that actin slides upon myosin. So when I muscle contract, what's going on? Actin is sliding upon myosin. So those cross bridges are occurring. So here's the other thing. Coming back to the stomach, the abdominal muscles, right? So when you just like tighten those muscles, but you're not like shortening them, you're just tightening them, what's going on? You've got the cross bridge is connecting. That's the beginning part of a contraction, but that's this type of contraction, an isometric contraction is just where you have no movement, no shortening of the muscle fibers, but we have connection of actin and myosin. Myosin, actin. Now, when they move, we have this taking place. I'll show you a video of this next class to reinforce this. Actin is sliding upon myosin. When the cross bridges occur, that's an isometric contraction. When we have shortening of the muscle belly, that's an isotonic contraction. There's two different types. Remember I said two different types of contraction. So I don't want to get you too much right here. I'm sorry. I'm just trying to give it to like as basic as I can. But realize this. See where it says ATP in yellow? ATP. So that needs to be present for us to have a separation, right? So there needs to be like a separation that takes place between the cross bridges. If ATP is not there, it's not happening. So if you're dead, if you've passed on to this life to the next, are you producing ATP? You're not producing ATP. You're not producing anything. Maybe a little bit of gas that's coming up. Other than that, you're not producing anything as far as ATP. Definitely not. And as such, are you going to be stiff? You're going to be stiff. Your muscles are going to contract, and they're not going to relax until the body degrades. That's sad, right? The body degrades. You're dead. That's what happens. Go ahead. Oh, I don't know. I don't really know what goes on anymore, to be honest. I mean, so, so I do. So they'll glue like the eyelids and such. And so I had a good friend. We never got into the details of mortuary science. But I think he was a funny dude. He was like one of the funniest guys I've known. And imagine, right? Like if you're working with, that's got to be hard. So he had a good personality, good sense of humor. So anyway, what happens? I'm sorry, I don't know. Unless you've watched videos of this, maybe you can tell me. Okay. Go ahead. Yes, Ellie.
So this is also unrelated to that, but does formaldehyde make anything like?
Yeah, so I don't really believe that they use formaldehyde anymore.
Oh,
I believe they use different other chemicals that are less less terrible, less noxious. Like that's a pretty strong chemical, and I don't think that they use it, but I could be wrong. But I know as far as preservation of, so say like I worked in a cadaver lab in chiropractic school for 1 year. We had full bodies for 6 months. We had parts of bodies sections for 6 months. Yeah, that was pretty wild, and it was pretty intense. And so, like that. Now, were the muscles all tight? No, it wasn't that, because these were preserved specimens and such. And so they didn't use formaldehyde. I know that. They used other chemicals and stuff. But it still, did it not smell so good? Yeah, it smelled kind of weird.
Well, it
Yeah.
almost like not being stiff, I guess is what I meant.
Yeah, so they weren't. That's correct. They weren't. Yeah, so you could actually, honestly, you could actually move the different body parts at the joints. Yeah. I mean, not as smooth as us, because we're producing synovial fluid in those synovial joints, those fluid-filled joints. Is the dead body producing ATP? No. Is the dead body producing synovial fluid? No. Right. So just what's there is there. All right. So let's get back here. So the statement here, rigor mortis, body cells stop making ATP. The myosin cross bridges with actin cannot break up after the power stroke or the movement. So we end up having an issue where the muscles will lock up, and it can last from a day to 60 hours. Okay. Okay. Now, this next slide that I want you to focus on. So when the muscle and the nerve, because there have to be nerves sending electricity to the muscle to allow for it to contract. Understood? So we call that, so muscles are excitable. Because we can have this electricity from the nervous system connecting to the muscle, so that when we send a nerve impulse, so how about this, folks? Now this is called a reflex. I touch something hot. Touch something hot. Does my hand stay on the hot thing? No. What happens? Whoa! Moves it right away, right? That's a reflex. Okay? It's a reflex. And so the nervous system, in particular, the nerves going to the spinal cord and then to the muscles of the upper extremity, allow for me to very quickly move away. Muscle tissue is excitable. It allows for that ability to be able to really, respond to this bioelectricity. Go ahead.
So this is kind of a weird.
No.
Is there like that disease where like the muscles people don't feel pain?
Yeah.
Is
So
that
yeah.
related to that?
So there are issues that can affect yet the peripheral nervous system, we would say. We're kind of getting ahead of ourselves. So remind me about that when we look at the nervous system. But know that, yes, absolutely, that there can be issues where people have a tough time experiencing and feeling pain. Would that be a good thing or a bad thing? How many of us have chronic pain? I have like a knee that I have to like get replaced. Do you have like chronic pain? Okay, yeah. So chronic pain, that means like you have pain a lot, right? And maybe not 100% of the, like 24/7, but you have it pretty frequently and maybe every day, right? To some extent. Having pain is no fun. It's terrible. Pain is no fun. But having pain is a good thing in that it tells you that there's a problem. Because if you don't have pain, so there are people who have Hansen's disease. It's called leprosy. And that affects the peripheral nervous system, the nerves in your body, and they don't feel like you or I do over time, and that leads to all kinds of bad things and infections that can take place throughout the body. It's terrible. So the ability to feel pain is not a bad thing. Now, let's come back here for a moment. So look up here on the board for me, please. I'm gonna, oh, by the way, lab quiz number 1 is the last week of October, just so that you know. Last week of October. All right, so I said to you that nerve and muscle meet, but they don't touch. They do not touch. And they do this at the NMJ, the neuromuscular junction, the nerve muscle junction. Okay. This will be the last slide for today. Let's see. Yeah. So the nerve and the muscle have to interact. And it's at that neuromuscular junction, at NMJ, or I wrote it over here, neuromuscular junction, the nerve muscle junction. And this is called a synapse. Synapse. And this allows for the nervous system to control the muscular system and allow for muscles to contract. Okay. All right. I believe that, folks, at this point in time, that's where we're going to stop for today. We'll finish this up on Thursday. Okay, good. So let's, folks online, I'm going to close out this portion of our class. I'm going to stop the recording.
This conference will now be recorded.
Okay, folks, so those of you, so classroom, just hold on a moment. I'm just finishing up here online. Just a moment. So here in documents and resources, let's see, I want to go to chapter 5 terms. Here we go. See in unit 1, chapter 5 terms, you'll click on that. You'll see the terms, and I would like you all to be able to define these terms, please, for me. There are 25 terms dealing with the chapter for bone. So I want you to do that. So the 25 terms, you'll define them. And just short definitions are fine. Okay. And remember, our quiz will be on this Thursday until Sunday. It'll be open for chapter 5. Very good. All right, folks. I'm going to stop recording.